What if the moon exploded tonight? The night the moon broke apart. Imagine stepping outside on a perfectly clear night. The streets are quiet. The stars hang above the rooftops, and the full moon shines exactly where it has appeared for billions of years. It looks peaceful, permanent, almost indestructible. Then, without warning, a blinding flash tears across its surface. For a fraction of a second, the moon becomes brighter than anything in the night sky. Cracks of white light spread across its face. Entire regions of the lunar surface begin lifting into space. And before anyone on Earth can understand what they are seeing, the moon explodes. There is no sound. Space is almost completely empty, so the explosion cannot send a noise across the distance between the moon and Earth. From the ground, the event unfolds in terrifying silence. The familiar circular shape breaks apart. Mountains, craters, and plains that have existed for billions of years vanish inside a rapidly expanding cloud of rock and dust. The object that has guided sailors, inspired civilizations, and illuminated the night is gone. In its place is a glowing wound in the sky. The explosion itself would have occurred more than a second before anyone on Earth saw it. The moon is approximately 384,000 kilometers away. Even light needs about 1.3 seconds to cross that distance. By the time the flash reaches our eyes, the moon has already been destroyed. For the first few moments, most people would not understand what had happened. Some would think it was an unusual eclipse. Others might believe an asteroid had struck the moon. Millions would reach for their phones. Cameras would turn toward the sky. Live videos would begin appearing across the internet. But as the cloud expanded, the truth would become impossible to deny. The moon was no longer a single world. It had become millions of moving fragments. Some pieces would be no larger than grains of sand. Others would be the size of houses, mountains, or entire cities. The largest fragments could remain hundreds of kilometers across. Because the moon was already moving around Earth at more than 3,000 kilometers per hour, most of the debris would continue traveling through space. It would not simply fall straight down. The fragments would inherit the moon's orbital motion, creating an enormous, expanding field of rock around our planet. For a brief time, the sight could be strangely beautiful. Sunlight would reflect from countless surfaces. The lunar debris cloud might glow like a silver flower opening in the darkness. Fine dust could spread into a brilliant halo. Large fragments would slowly separate, each following its own path around Earth. The night sky would appear filled with moving points of light. But this beauty would hide a catastrophic danger. An explosion powerful enough to destroy the moon would give different fragments different speeds. Some would be thrown away from Earth. Some would enter higher orbits. Some would collide with one another. And some would be pushed directly toward our planet. The first question scientists would ask would be simple. How much debris is coming toward Earth? Observatories would immediately begin tracking the largest fragments. Radar stations would search the sky. Space agencies would calculate thousands of new trajectories. Governments would activate emergency systems. But the debris field would be too large and too complex to predict quickly. Humanity has systems designed to track asteroids and satellites. It does not have a system prepared to follow an entire shattered moon. The earliest danger might come from objects already orbiting Earth. Thousands of satellites provide communication, navigation, weather monitoring, banking connections, television signals, and military surveillance. The expanding lunar debris cloud would not immediately reach most satellites, but fast-moving fragments and fine particles could eventually cross important orbital regions. Even a small rock traveling at several kilometers per second could destroy a satellite on impact. Communication networks might begin failing. Navigation systems could become unreliable. Weather satellites could vanish from monitoring screens. Astronauts aboard space stations would face an almost impossible situation. They would be surrounded by a growing field of objects moving faster than bullets. A fragment only a few centimeters wide could tear through a spacecraft. Ground controllers would attempt to calculate safe escape paths. But returning to Earth would also be dangerous if debris had begun entering the atmosphere. For people on the surface, the first hour could remain surprisingly calm. There would be no immediate giant waves striking every coastline. The atmosphere would not suddenly be pulled into space. Earth would not instantly change its orbit around the sun. The moon is extremely important, but its destruction would not cause the planet to explode. Gravity would still hold people to the ground. The oceans would remain on Earth. The night would continue. Yet the sky above would become increasingly unfamiliar. The moon's gravity would not disappear completely. Its mass would still exist inside the debris cloud. If most fragments remained close together, Their combined gravitational pull on Earth could initially remain similar to that of the original Moon. But as the debris spread across different orbits, that gravitational influence would become irregular. The oceans would begin responding to a changing and fragmented source of gravity. Normal tides are created mainly by the difference in the Moon's gravitational pull across Earth. The side of the planet closer to the Moon is pulled slightly more strongly than the far side. This helps create tidal bulges in the oceans. But now, instead of one large moon following a predictable path, Earth would be surrounded by countless fragments. Some would be closer, some farther away, some moving faster than others. The tides would no longer follow familiar schedules. At first, the changes might be subtle. High tide could arrive earlier than expected. Water levels might rise unusually in one region and fall in another. But as larger fragments moved into new positions, coastal systems would become increasingly unpredictable. Ports would close. Ships would be ordered away from shallow coastlines. Communities would prepare for flooding without knowing exactly when it would arrive. 3 hours after the explosion, the first fine particles might begin interacting with Earth's upper atmosphere. Tiny pieces of lunar rock would strike the atmosphere at enormous speed. They would heat up from compression and friction, creating streaks of light across the sky. At first, they might resemble an extraordinary meteor shower. Hundreds of glowing trails would appear every minute. People would stand outside watching. Some would celebrate, others would pray. But the meteor shower would continue growing. The dark sky would fill with fire. Small fragments would burn away harmlessly. Larger rocks could survive the journey. They would reach the surface as meteorites, striking oceans, forests, fields, and cities. Most would fall into the sea because oceans cover the majority of Earth. But even a small fraction landing in populated regions could cause enormous destruction. A rock only several meters wide could explode in the atmosphere with tremendous force. A fragment tens of meters across could flatten a city. A piece hundreds of meters wide could devastate an entire region. And somewhere within the debris cloud, fragments far larger than that could already be moving toward Earth. Governments would face an impossible decision. Which locations should be evacuated? Where could people go? Underground shelters could protect against small impacts and airbursts, but no shelter near the impact point of a massive lunar fragment would guarantee survival. Military radar systems would detect objects approaching from multiple directions. Warnings might arrive only minutes before impact. Sirens would sound. Emergency messages would appear on screens. People would rush into basements, subway tunnels, mines, and bunkers. Highways would become blocked. Airports would close. Families would look upward at a sky filled with glowing lines and wonder which one was coming for them. 6 hours after the moon exploded, the first major fragment enters Earth's atmosphere. It may be only a few hundred meters across. Compared with the moon, it is tiny. Compared with a city, it is enormous. The fragment strikes the upper atmosphere at several kilometers per second. The air in front of it is compressed and heated into plasma. The night briefly becomes brighter than day. A shockwave spreads across the sky. Windows shatter hundreds of kilometers away. The object crashes into the ocean. For an instant, the sea opens around it. Billions of tons of water are thrown upward. A vast cloud of steam rises into the atmosphere. And from the impact point, a tsunami begins traveling across the ocean. The moon has been gone for only 6 hours. But its fragments have already begun reaching Earth, and the largest pieces are still above us. A world without the moon. The first ocean impact sends waves outward in every direction. Near the impact zone, the water rises like a moving mountain. Ships vanish beneath it. Small islands are completely overwhelmed. As the tsunami travels across the ocean, it spreads over a wider area, but it remains powerful enough to threaten coastlines thousands of kilometers away. Coastal cities receive warnings. Millions attempt to move inland, but roads are already crowded with people escaping possible meteor impacts. Electricity fails in several regions. Communication networks become unstable. Satellites are disappearing from orbit, and the sky continues burning. During the next 24 hours, thousands of lunar fragments enter Earth's atmosphere. Most are small. They create brilliant flashes and disappear before reaching the ground. But hundreds survive. Some land in empty deserts. Some strike forests and ignite fires. Others hit cities, power stations, highways, and farmland. Every impact adds another crisis. Emergency services cannot reach every location. Hospitals are overwhelmed. Aircraft cannot fly safely beneath a sky filled with unpredictable debris. Ships remain vulnerable to both falling fragments and violent seas. The world enters a state of continuous alarm. Yet the greatest danger is not the number of small impacts. It is the possibility of one truly massive fragment. If a piece of the moon several kilometers wide struck Earth, the energy released would be greater than the combined power of humanity's largest weapons. The impact would create a crater tens of kilometers across. Rock and dust would be launched high into the atmosphere. Earthquakes would spread through the crust. If it struck the ocean, mega tsunamis could cross entire ocean basins. If it struck land, cities hundreds of kilometers away could be destroyed by heat and shock waves. A fragment tens of kilometers wide could affect the entire planet. Dust thrown into the upper atmosphere might block sunlight for months. Temperatures would fall. Crops would fail. Food chains would collapse. The immediate impact would be devastating. The years that followed could be even worse. Could humanity destroy an approaching fragment? Modern space agencies have begun developing ways to alter the paths of asteroids. A spacecraft might strike an object and slightly change its direction. Nuclear devices could potentially break or deflect some targets, but those strategies require time. A small change made years before an impact can save a planet. A change made only hours before impact may achieve almost nothing. The lunar debris would be close. Some fragments could arrive before rockets were even prepared. Others might remain in unstable orbits for months, years, or centuries. Humanity would not face one asteroid, it would face an entire system of them. After the first days, the debris around Earth might begin forming a temporary ring. From space, the planet could resemble Saturn on a much smaller scale. Countless rocks and dust particles would orbit near the path once followed by the moon. From the ground, the ring could stretch across the sky as a glowing band. Depending on its angle, it might appear as a bright arch reaching from one horizon to the other. At night, sunlight reflected by the debris could make true darkness rare in some regions. The ring would be magnificent. But it would also be unstable. Fragments would continue colliding. Each collision would create more dust and smaller rocks. Some material would escape Earth's gravity. Some would gradually fall toward the planet. The meteor storms might continue for generations. Every night could bring new objects into the atmosphere. Human civilization would need to adapt to a sky that was no longer safe. Buildings might be reinforced. Critical facilities would be moved underground. Cities could install impact shelters. Satellites would become difficult to maintain because the orbital environment would be filled with debris. Humanity might lose reliable space-based communication and navigation for decades. Weather forecasting would become less accurate. Global communication could become slower and more dependent on cables and ground-based systems. Space travel might become nearly impossible. Earth could be surrounded by a deadly barrier of moving rock. Even if the major impact stopped, the loss of the moon as a single stable object would transform the oceans. If much of the debris remained spread around Earth, the combined mass would still produce gravity. But its tidal influence would be divided and constantly changing. Instead of two predictable high tides and low tides in many regions, coastlines could experience irregular surges. Some days might bring unusually weak tides. Other days could bring powerful changes as large fragments aligned with Earth and the Sun. Fishing communities would struggle. Ports would become harder to operate. Coastal wetlands would change. Many marine species depend on tides for feeding, reproduction, migration, and protection from predators. Crabs, shellfish, sea turtles, fish, and countless microscopic organisms have evolved around lunar cycles. Their biological rhythms could be disrupted. Coral spawning events linked to moonlight might change. Animals that navigate using the moon could lose an important guide. The disappearance of normal moonlight would also transform life on land. Many nocturnal predators use lunar brightness to hunt. Other animals hide during bright nights to avoid being seen. Without a stable moon, these relationships would shift. Some species would adapt, others could decline. The effects would spread through food chains. Human culture would also lose one of its oldest symbols. There would be no familiar full moon, no crescent hanging over the horizon, no predictable lunar calendar. Religious festivals and traditional celebrations based on lunar cycles would need new methods of calculation. Poetry, mythology, navigation, and art would all carry the memory of a world that no longer existed. But the deepest long-term change could involve Earth's rotation and axial stability. The moon helps stabilize the tilt of Earth's axis. Our planet is tilted by approximately 23.5 degrees, which helps create the seasons. The moon's gravitational influence prevents that tilt from changing too wildly over relatively short geological periods. Without a single stable moon, Earth's axis could become less predictable over millions of years. The change would not happen overnight. Humanity would not wake up the next morning to a new climate. But across enormous stretches of time, Earth's tilt might vary more dramatically. Seasons could become more extreme. Polar regions might receive more sunlight during some eras and less during others. Ice sheets could grow or disappear. Deserts could shift. Habitability across the planet could slowly change. The moon also affects the speed of Earth's rotation. Through tidal interactions, it has gradually slowed our planet over billions of years. Long ago, Earth's days were much shorter. Without the moon as a stable companion, the future evolution of the length of the day would change. Again, this would unfold extremely slowly. The immediate survivors would never notice it, but the planet's long-term rhythm would no longer follow the same path. After several months, the worst meteor bombardment might begin to decrease. The most unstable fragments would have already fallen, escaped, or entered more predictable orbits. Surviving governments would begin rebuilding. Coastal regions destroyed by tsunamis would be abandoned. New cities might rise farther inland. Underground shelters would become permanent parts of civilization. Astronomers would create detailed maps of every large lunar fragment. Instead of predicting weather alone, daily broadcasts might include orbital danger reports. A new object could be identified years before a possible impact. Humanity would build spacecraft designed to push dangerous fragments away. Planetary defense would become one of the most important industries on Earth. Children born after the explosion might never see the original moon. They would grow up beneath a ringed sky filled with moving lights. Their parents would describe a large silver circle that once rose above the horizon. To those children, the moon might sound like a lost world from mythology. Eventually, one of the larger fragments could become dominant. Through collisions and gravity, debris might slowly gather into new bodies. A smaller moon could form, or several tiny moons might orbit Earth. This process could take thousands or millions of years. The new moons would not look exactly like the one humanity knew. They might be irregularly shaped. They could travel through different orbits. Their tides and phases would create an entirely new rhythm for Earth. But would humanity survive the initial destruction? That would depend on how violently the moon exploded. If most debris remained in stable orbit and only smaller fragments reached Earth, civilization could survive, although millions of lives might be lost. If multiple massive pieces struck the planet, the event could cause a global extinction crisis. The difference between survival and collapse could be determined by only a few fragments. That is what makes this scenario so terrifying. The moon appears gentle from Earth. It moves slowly across the sky. Its light is soft. Its surface is silent. But the moon contains an almost unimaginable amount of rock. It has a mass of more than 70 billion tons. Turning even a small fraction of that mass into Earth-bound projectiles would release devastating energy. Fortunately, there is no known natural process likely to make the moon suddenly explode. It has survived asteroid impacts, volcanic activity, and billions of years of cosmic history. It is slowly moving away from Earth by only a few centimeters each year. For the foreseeable future, the moon will remain above us, stable, silent, and whole. But imagine looking up tonight and seeing a crack of light appear across its surface. Imagine watching the familiar face of the moon divide into pieces. Imagine realizing that every glowing fragment in the sky could become the next object to strike Earth. The moon has always been our closest companion in space. It controls the tides, stabilizes our planet, illuminates the night, and records the violent history of the solar system across its scarred surface. We often look at it and see beauty, but if it ever broke apart, that beauty could fall from the sky.